Welcome to Maths for You channel. A past question on series from Oxford and Cambridge past paper. Chris runs half marathons and is following a training program to improve his times. His time for the first half marathon is 150 minutes. His time for his second half marathon is 147 minutes. Chris believes that his times can be modeled by a geometric progression, GP. Chris sets himself a target of completing a half marathon in less than 120 minutes. Show that his model predicts that Chris will achieve his target on his 13th half marathon. So he will run this his half marathon in less than 120 minutes after 13 marathon because of his progressing on geometric progression model. Let's do that first, and then we'll come to the next second and third part. So the first half marathon was 150. So A is 150, and the second marathon is 147. And again, his model is geometric progression, GP. So that the first one is A 150, AR is 147. 147. So R is equal, it's AROR is 147 over 150, that is 0.98. So R, the common term, is 0.98. So the any number UN, any term, or any marathon in its term, any half marathon is UN equal A times R to the power n minus 1. That's a standard formula. So if you could use that, UN equals, so it just it could be second, third, fourth, fifth, or 100th, or whatever, in the UN equal 150 times 147 over 50 n to the power of n minus 1. That's the standard formula. And again, what they say is that the UN is the time taken for a particular marathon is less than. So it's actually progressing from 150 and improving it. So just when you come to just make this half marathon in less than 120 seconds, it's UN. And it's whatever number. So if you could, UN is the same thing, 150, 147 over 50 to the power n minus 1. That is less than 120 minutes. So if you could work it out, it's 147 over 150 to the power of n minus 1 less than, cross multiplication is 120 over 150, that is 0.8. And again, 147 over 150 is 0.98. So 0.98 to the power n minus 1 less than 0.8. Then to solve this, and of course we have to take log. It can be a 10 base log. I just did this, the ln. So ln of the 0.98 to the power n minus 1 less than ln, both sides, we have to take both sides log 0.8. Then the power is n minus 1, become multiple, so n minus 1. And again, ln 0.98 is minus 0.020. And less than, again, ln 0.8 is minus 0.2231. Then from that, minus cancel, but we can't see this inequality. Therefore, if you multiply minus both sides, the sign will change. So the sign change for n minus 1 greater instead of less than is greater now because of we multiply by minus both sides. So that n minus 1 greater is 0.2231 divided by 0.0202. From that, it's to do a workout, and then it comes n is greater than 12 point blah blah blah. So he will actually do 13 half marathon. It will be less than 120. So it's just up to 12 half marathon is over 120. But this, of course, the n is the integer. N must be integer. So this n is greater than 12 point something. So that is n equals 13. So 13th half marathon, it can runs in less than 120 seconds. That's minutes. That's the first part. And again, it says that it's proved that a 13 half marathon. Right, okay. After the second part, after 12 months, Chris has spent a lot of, Chris has spent a total of 2994 minutes to the nearest minute to the running half marathon. Use this model to find how many half marathon he has run. So the model is the geometric progression. This says the total every marathon he actually runs says about 150, 147, and less. Just when you come to 13, less than 120, whatever. So the total the time he run half marathon, it could be as many marathon as possible, 2974 minutes. So that's the total. So SN. So geometric progression or geometric series, Sn equal A times 1 minus r to the power n divided by 1 minus r, because of r is less than 1. Therefore, this is the standard formula. But the Sn is so the total time in minutes 2974. Then we need to find how many marathon he has ran to achieve that many minutes. So 150, A is 150, 1 minus 0.98 to the power n, because r is 0.98, and divided by 1 minus 0.98. That is 150 times 1 minus 0.98 to the power n divided by 0.02. Then if you could cross multiply that, it's 2974 times 0.02 equal 150, 1 minus 0.98 to the power n. So if you could work out bring the left hand side, 1 minus 0.9 to the power n equal 150 divided by 150 is 2974 times 0.02 divided by 150. And then again, it just work out as it's 0.98 as 0.98 to the power n equal, if you take the minus the other side, the 1 the other side, and take 0.9 to the power n to the other side and bring the other one to this side and work out in a calculator work and this. So again, so to find n, a log. So if I take log both sides, and n is the power, so n times log 0.98, and that will be is a denominator here. So the log 0.6035 divided by log or ln 0.98. Then the answer is 29.9. So obviously that n is the integer, so this 25. So he should have, or he would have ran 25 marathon in order to run that many minutes. That's 2974 minutes. Right. That's the next one. Give 2 reasons why this model may not be appropriate when predicting the time for half marathon. Yes, this is a model that he actually ran every marathon and is improving it. But there are different influences, so the performance cannot be constant or cannot be sort of improving it all the time. He's human. So is the performance cannot continue due to physical and external influence. So it just surely it can't use the model all the time. It will, the age and things, it just it'll affect. So it cannot improve it every time. That means you can actually run the marathon in a minute. That's not possible. So that's it. So it's physical and external influence will affect. Therefore, the model is quite right. It's okay for a short period. Otherwise, it won't be right, or it won't give the right answer forever. Thank you. Please subscribe the channel and share the contents with other students and friends, please. Thank you.